1370 WOCA.
Ocala.
All right, 5 minutes after 10 o'clock. Thank you for tuning in. So on Friday, we got the book called Einstein's Lost Key. I was looking forward to reading the book, so I took it home over the weekend.
It is so great.
Now, this is a book by Alexander Unzicker. He's on the phone, and he is a German physicist. He's a science writer. He has degrees in physics and in law and a PhD in neuroscience. He's writing about Einstein, and I think I'm going to sit on my little my little chair, my little comfy chair with some crackers,
Yes.
and absorb this whole thing in a weekend. It's over my head, Robin. I'm telling you.
I know, but it's interesting.
But anyway, it is such a fascinating topic. If you think about Einstein's Lost Key, the subtitle actually will give you more information. How we overlooked the best idea of the 20th century. For the longest time, I've always felt like in watching Einstein that he spoke to me. Now, this is just my own opinion. That he spoke like a man who obviously believed in science and what science means, and as well as in God. And there was not a conflict because of those two things. That's the way I always viewed when I would listen to him talk. I'm not an expert at all, but on the phone is Alexander Unzicker calling in, I think, from Germany, right?
Yes.
Am I right about that? Good morning, Alexander. How are you?
Hello, I'm fine. Hello, everybody. Yeah, I'm calling from Germany, from Munich.
From Munich. What's the weather like today?
Oh, it's sunny, but very, very cold. We are, below zero, and, yeah.
Well, we're in Florida. I don't want to rub it in, but it's kind of nice.
Yeah, I just come over.
That's right.
One of the things that we often credit Einstein with, I think, is something he wished we wouldn't credit him with, and that's the atomic bomb. Am I right?
Yeah, he played a role. He played a role in the development of the atomic bomb, but not a decisive one. I think it's a technology that would have developed in any case, and pretty much without him, without his contribution. Yeah.
So we're going to learn from you a little bit in the interview, but even more so when we read the book about the overlooked idea of the 20th century that maybe is it not too late? Can we now look at it closer? Maybe use this idea.
Well, it's never too late to look at a very good idea. I think it's the right time right now. We have 100 years of relativity, and his best idea that has been overlooked is that his most important theory, general relativity, his famous theory of gravity. It can be phrased in a much simpler way that yields to a much better understanding of cosmology. Yeah.
Can you help me understand it?
Okay. So I think we should, for the audience, we should start for what's general relativity? What's the idea behind? And to put it in plain words,
okay,
gravity deflects light. Okay, light rays are bended by gravity. So, given this, Einstein's very first idea to explain this was, well, it works as in optics. It's a well-known phenomenon that whenever light enters a place where the speed of light is lower, it has to deflect. It has to change its direction. It's getting deflected. So his idea was to describe this gravity, this effect of gravity, as optics. Whenever light enters water, it's refracted. Whenever it enters the atmosphere, the light ray is bended. It would work the same way. And this is a much simpler explanation of gravity than the conventional theory that explains it in a geometric formulation with a lot of mathematics. And,
right.
Yeah.
So
that will help a lot.
Does it slow down? Does light slow down when it enters water?
Yes, it's slowing down. And so it slows down when it's in the vicinity of a massive body. Yeah? The point is that you don't notice it immediately because if we measure the speed of light, okay, how do we measure the speed of light? We do it measure with the speed of light itself because it provides frequencies and wavelengths, and we use our atoms. And of course, if the speed of light is lower, also the atoms would oscillate with a lower frequency. So you don't notice it immediately, but the effect is there. It provides an alternative explanation of gravity, and that would be a much better point of view. In particular, with cosmology, we would get a really new picture of cosmology.
Okay, so let me see if I can ask some questions that I don't know if this is going to, and we'll stop if I'm going in the wrong direction, but. Okay, if I look out in the sky at nighttime and I see all the stars, and I understand that the light I'm looking at happened millions of years ago because of the whole light year thing, okay? To me, that means that there might be stars out there that were born, but more recent, so we don't see them. In other words, the light it didn't reach us yet. Am I right? There are some stars out there who have light that hasn't reached us?
Yeah, of course. If you look at the galaxy, say 5 billion light years ago, that we see the light that has been emitted 5 billion years ago. That's always that would, by the way, wouldn't change very much. The thing is that what would change is when by the way, the first one who discovered the galaxies was American astronomer Edwin Hubble, and he discovered that the light of these distant galaxies is redshifted. It seems much redder than the usual light. So back then, the interpretation was, okay, why is it redshifted? It seems to move away from us. And that has been the dominating interpretation since then, that led to an expanding universe.
Okay, the one thing I want to make sure that I understand before we're done here, I still don't know that I understand. What is the best idea that we haven't used?
Yeah, the best idea we haven't used it is explaining the motion of light with also assuming that it can be variable, the variable speed of light. If you look at this, the difference is there. What's our basis of our picture of cosmology is the Big Bang. Everybody talks about the Big Bang.
Okay.
Now, what's the Big Bang? Why do we think about? Why are we convinced that there was a Big Bang? Because the universe seemed to be expanding since this observation by Edwin Hubble. But if you phrase it in the way Einstein looked at it back then, if you consequently apply this idea, that it would be very different. Nothing would expand. This expansion would be just an illusion, and all what happens is that light spreads. That's all.
Oh, really?
Okay?
Oh, that is
there
it.
There would be no material expansion of the universe and no Big Bang in the conventional sense, just a moment where light started spreading.
Okay, so it looks like it's expanding because gravity is slowing light down.
Exactly, yeah.
Okay, and does that lend itself to any usable theory? Like, can we use that information in any way?
Well, in an abstract way. I mean, if you think about cosmology, it's not a very direct use. But, I always make the joke, two planets there are two planets in the universe, and one planet says, how are you feeling? And the other one, oh, terrible, what's up, what's the matter, what happened? I've got Homo sapiens. And then, oh, don't worry, that will go away by itself. So we have
That's funny.
We have a lot of problems. We have a lot of problems on the planet, and for many of them, there is not an immediate solution, not an immediate use. But if you look at the history of humankind, at the history of civilization, it's in first place. It's not so much a history of wars and leaders and countries, and it's a history of technology. And technology is a history of scientific insight. So I'm convinced that our destiny on the long term will critically depend on how deeply we were able to understand the laws of nature. I really believe this. Yeah.
I was really really enthralled with your book, and I was able to read parts of it, and I didn't realize that Einstein was a philosopher until I read about Abraham Pais, Pais. And
Yes,
how
yeah,
and that was really fascinating to me, because I always thought of Einstein as a scientist and not in the philosophical realm.
Yeah. Yeah, but you have to realize that these two faculties, so to speak, were one at the time back then. Einstein had a very philosophical attitude towards physics. He wanted to understand why. He asked why. He wasn't happy with a description, with some new data, new experiments, and that's the big difference between the way science was done at the days of Einstein and how science is done today. Yeah. And in this sense, I think science should change a lot, or should think about Einstein much more.
We have to take a little break. Alexander Unzicker is on the phone in Munich, Germany. He is a German physicist. The book has a lot of equations that were way over my head. Don't even know what I'm looking at. The book...
You really need them, okay?
I know. No, you do a good job in the book. Explain. The book is called Einstein's Lost Key, How We Overlooked the Best Idea of the 20th Century. We'll be right back.
Mm-hmm.
The weather is brought to you by myfwc.com. Safe boating is no accident. On this Monday, mostly sunny but cooler than recent days with a high of 58 to 62. Clear and rather cold Monday night with lows ranging from the mid-30s inland to the low 40s on the coast. Tuesday, partly sunny and quite cool, high 54 to 58. The Wednesday, times of clouds and sunshine, high 62 to 66. From the Florida Weather Center, I'm meteorologist Joe Lundberg.
Ooh, ouch. Does pain have you glued to the couch? Yes, unfortunately it's true that every year we must get older, but that doesn't mean we have to deal with pain in our back, knees, or shoulder. If your muscles and joints are sore, don't worry anymore. Come get acupuncture from me and you'll be pain-free. Acupuncture starts as low as $35 at a Better You Healthcare. Call me, Dr. Erica Olstein, at 615-5566. Stop your pain from driving you insane.
It's 17 minutes after 10 o'clock. Thank you for tuning in. We were at Rainbow Springs on Saturday, and they're starting a butterfly garden. Mm-hmm. And the rules are, because it's a state park, they have to only have native plants from Florida, plants that are native to Florida, yep, because they thrive better in their native environment. Mm-hmm. My mother was born in Germany.
Yes.
Maybe I would thrive better if I could transplant myself over there.
And you go back to Germany.
Oh, I didn't have the button pushed. Oh man, our guest didn't hear what I said.
Oh, darn.
Alexander Unzicker is on the phone. His book is called Einstein's Lost Key. Alexander, we've got the phone ringing. Are you okay with taking phone calls?
I'm okay. I can hear you.
Okay, excellent. Thank you. Good. Oops, let me push the button here. Hold on a second. Good morning. You're on the air. Thank you for calling.
Yes, good morning. Yes, very interesting subject. Kind of harkens me back to the days when I was reading Professor George Gamow's works. I think you cover some interesting territory.
Oh man, you would love this one, I think. All right, thank you for the call.
Hang up now. Bye.
Thank you. What does this change anything about what we think Einstein was trying to tell us about time, or is this separate from the time theory?
Of course, it does. Time does matter a lot. It's a very important topic. I would like to refer to the sir who called him. He mentioned George Gamow, and I'd like to mention that there is a very interesting relation of Einstein's idea to an idea of Paul Dirac. Paul Dirac was a Nobel laureate, famous physicist, and he had very interesting ideas about cosmology too, which is called the large number hypothesis. And George Gamow was also had made interesting contributions to this large number hypothesis. And I think there is a deep link between these two geniuses, Einstein and Dirac. And let me say, to somebody it might seem like a bold claim. I'm claiming that there is a new kind of Big Bang and so on, and current cosmology is wrong. That sounds very audacious. But at the very least, what I can say is that there is an undiscovered relation between these ideas of Einstein and these other ideas of Dirac, and it's demonstrably related.
Really?
Demonstrably, these two very maybe the two greatest physicists of the 20th century. They didn't talk about cosmology. I think this is a historic.
So help me understand here. If Big Bang Theory, the way I always understood it was there was one big mass where everything was, and then it exploded. And when it exploded, everything shot out from the center, and that's what we have now. So is that not true? Or, I mean, does it change that theory? And if it is true, then wouldn't the particles be expanding? I'm trying to figure out why they would stop expanding at some point.
Yeah, I mean, if you follow this idea of Einstein, there is no expansion of material at all. It's just that light spreads, and the idea is that matter influences light. Okay, matter slows down light. So even if you have just light spreading, you have always a larger horizon, a larger sphere where light spreads. So there are always more masses in it, and if the masses decrease the speed of light, during the cosmic evolution, the speed of light would decrease continuously.
Does light ever stop?
No, it would never, not really stop. Just slow down in proportion to the surface of the sphere, but it will. The speed of light cannot just decrease. It influences also the wavelength and the frequencies of light, and for that reason, very simple reason, it would appear redshifted to us. That, by the way, was not. I'm slightly exaggerating here because that consequence hasn't been drawn by Einstein. That was an idea by American astrophysicist Robert Dicke. He's a well-known astrophysicist, a very, very talented experimenter, but he had made incredible contributions to theory. And there is also a close relation to his 1957 theory of gravity of Robert Dicke and to this 1911 idea of Einstein's. And also, these two didn't know about each other. Dicke unknowingly used the very same equations, the very same formulas that Einstein had used in 1911. Yeah?
And it's very interesting that Newton is brought into the picture in your book.
You mean in chapter 11, Newton?
Yes. Yes.
Yeah. Yeah, that's a big question. What's your question about that?
Oh, because it seems like some of the powers that were at that time, like Einstein and his Kuhn, that they were kind of taking apart Newton's theories. But in reality, when Newton came up with these theories, a lot of these other parts of the equation didn't even exist back then.
Mm-hmm. Yeah, of course. Yeah. Yeah, unfortunately, people are much too. They don't really respect the history of science. They're not really. They're often today's scientists are quite ignorant about the historical development, how science developed, how many times science went into the wrong directions. And if you look at this, if you read books like Thomas Kuhn's The Structure of Scientific Revolutions, you have at least to consider the possibility that we might be mistaking our current model. That is, a thing that's born a couple of years ago, or let it be 20 years ago.
So do I understand it right that gravity not only slows down light but also bends it?
Yeah, that's a direct consequence because it's as light would be intelligent and search the fastest way from point A to point B.
Right.
So let me make an example. If you look at the river and a person is drowning, you're not running the direct path to the river and then start swimming. You take a longer path where you can run faster, and then you take a shortcut to save the drowning person. So what you're doing is to minimize the time, and that was light automatically does when it encounters a region where the speed of light is slower.
So, okay, this might sound like the dumbest question you've ever heard, but here's my question. It sounds like it's possible that light could make a U-turn. And if, just hear me out, because it might be dumb. It probably is. But
Gee.
is it possible that when we look up in the sky with the Hubble, that somewhere millions and billions of years ago is the light from our own sun? I mean, could we be seeing our own light, but up as a star? But billions of years old.
Mm-hmm. Well, that's not a stupid question at all. I mean, I think if you extend this theory of Einstein, I would call it Einstein decay theory. If you try to extend this to the level of elementary particles and ask what conditions could happen that make light turn around in a circle, so to speak. That's a very interesting question, and that I think there is a lot of potential in this theory also for the microscopic physics. On the level of cosmological scales, I don't think that you literally would observe a light making a U-turn, because there is just not mass enough. Mass is not concentrated enough to have this effect. But in principle, masses do bend light. Yes.
Because there was a story just a few years ago about a discovery that some scientists concluded that we see the same star twice because it's behind a body of gravity, like a whole galaxy is splitting the light, so we see it to the left and to the right, and we see the exact same star twice. But in fact, it's behind the galaxy or whatever that's bending that light.
Yeah, exactly. That's what's called a gravitational lens. There's a whole industry of gravitational lensing, and that light is bended because the gravity bends this light, and it's called lens because it's the exactly analogous situation as a lens of glass that bends light. And all astronomers are speaking about gravitational lenses. That's a thing that's astonishing, and they're not realizing that their wording is so close to this theory of Einstein. It's much closer than they think about.
All right, does the solar system have a gravity, just like each planet has a gravity? Like when light passes our entire solar system, does it get bent simply by the mass of, even though we're all separate particles?
Yeah, I mean, that's where the Einstein's theory was famously confirmed in 1919. British astronomer Sir Arthur Eddington made this famous excursion to the eclipses, and he was able to demonstrate that the sun was deflecting light by a very tiny amount of 1.7 arc seconds. That's like the distance that's like a finger on say 2 miles or something. Okay.
Oh wow.
A very tiny angle. He was able to measure with the technology of back then. Yeah.
Wow.
Alexander, thank you so much for coming on the air and for putting radio guys in. I mean,
this is wonderful.
You're definitely speaking over our heads. Einstein's Lost Key. I have a copy of the book. If you want the one that was sent to us, please call me. I'll leave it here for you. The rest of us have to go buy it. Do you have a website, Alexander?
Yeah, it's just alexanderunzicker.com, alexanderunzicker.com, or even einsteinslostkey.com is another site. Well,
okay, Einstein's Lost Key. Let me give this one away. Good morning. You've got the book. Who's this?
This is Jim. Thank you.
I knew you'd like it, Jim. It'll be waiting for you.
Thank you very much.
Thank you. Alexander, it's an honor to be able to say we spoke to you today. Thank you so much for being on the air with us today.
Okay, thank you.
All right.
Thank you.
We'll be right back.
Fox News Radio, I'm Pat O'Neill. Security forces in Iraq going door-to-door in Baghdad looking for 3 Americans reportedly kidnapped over the weekend. Secretary of State John Kerry.
We have pretty strong indications of where this might have emanated from, and we're working very hard with the Iraqi authorities, and hopefully we can secure their release.
One official says they were kidnapped from their interpreter's home. Central Florida residents surveying damage after weekend tornadoes that killed 2.
A roof shattered here on this home, a yard littered with debris, a car smashed. This is only one area hit by that EF2 tornado.
Shayla Reeves of Fox affiliate WTBT in Sarasota. The search resuming today for a ski instructor who went missing in Northern California. Yesterday's search for Carson May was cut short because of avalanche danger. Fox News, we report, you decide.
Any Jane Doe can tell you that Geico could help you save. But since money talks, we just ask the savings instead.
Greetings and sun salutations. I'm Jane's Money, and I never knew my self-worth until Jane switched her car insurance at Geico.com. Those 15 minutes built me up to real savings. Geico's been helping customers save money like me for over 75 years. So take that to the bank. And namaste.
Geico. 15 minutes could save you 15% or more on car insurance.
Without automatic cloud backup, everything on your computer is at risk. From hackers, viruses, natural disasters, or even the occasional human error. Few things are as bad for business as downtime. So why take the risk? Get Carbonite Cloud Backup and protect all the files that keep your business or your home running smoothly. Start your free trial today at Carbonite.com. No credit card required. Use the offer code INFORMATION to get 2 free bonus months if you decide to buy. That's Carbonite.com. Offer code INFORMATION.
We're saving thousands with Robert Palmer.
So rule number 1 is always shop around. Always shop around. If you're trying to get a mortgage, if you're trying to get the best credit card, if you're looking at student loans, cell phone bills, you name it, rule number 1 is always shop around. Always shop around.
That's rule number 1, just one more vital part of fighting back to stop being a financial zombie. Yes, you can take the mystery out of the complicated world of finances, take charge